Hello and welcome to this Haas tip of the day. So we want to program a CNC mill. So you pull out the manual and you start reading. That is a lot of code. Now those aren't really our manuals, this guy is. But still, there are enough codes in here to choke a horse. So where do we start? Inside this envelope are the top secret 9 lines of code that every CNC programmer knows. The 9 lines of code that you need to fully understand before you write your first program. So stick around as we look inside. Everything for me begins with my setup sheet. So check this out. I've got a block loaded up. Now if you're tightening up those tools by hand, you have been preparing to be a CNC programmer your entire life. You might just not know it. Our moms, our teachers, and even the Cookie Monster started off teaching us how to count cookies before we could ride a bike. And by kindergarten or first grade, we took those numbers and laid them across a number line from 0 to 10, but all on a single axis. And by 5th grade, they added another axis. And we started plotting pairs in both an X and a Y in a single quadrant. And then by 6th grade, our minds were blown when they started adding in negative values, negative numbers. We now had both positive and negative X values, positive and negative Y values, and we were taught to plot coordinate pairs in all 4 quadrants. It started to look like a CNC machine. In fact, just about half of our 6th grade math class was basically an intro to CNC programming class. Now with these templates, they've made things incredibly easy for us. All the lines that are connected are called a shape. Shape 1, shape 2, shape 3. And they gave us very specific instructions. We can plot each point on the axes and connect them in order. Do not connect the shapes to each other. This makes sense. We grab our pen or pencil, we're going to draw the shape. When done, we pull our pen off the paper, move to the next shape, come back down the paper, continue with that second contour. Now these templates are everywhere on the internet. You can find tons of them just by Googling graphing coordinate pairs, or you can create your own. So having mastered the art of middle school graphing of coordinate pairs, we can prepare to move from this to machining on actual machines. But we need some codes. Tyler, the envelope, please. Perfect. These are what I think are the 9 most basic lines of code that every CNC programmer knows. Before you can program this, you need to understand what each and every one of these lines does. This is where we start. Now, don't worry about writing all this down. We'll link to this document in the description of the video. Now, these look like pretty simple codes. You probably already know them if you're already a programmer. But the bonus content that you'll download is kind of an expanded version. It'll have these basic 9 lines of code for mill. In the bonus content, we'll add the 9 lines for lathe, and we'll also give you what to study next, the more advanced codes. Because just about every part that you will ever program can be made using just the codes on this sheet. A really, really good resource. We've boiled down that entire manual into a single page for you. Now, right in the middle of these 9 lines of code is a little section that's labeled dot to dot XYZ locations. Now these are simply the dot to dot points that we've all been graphing since 6th grade or earlier. If you put together enough shapes, you've got a CNC program. You can engrave, you can face, you can machine the perimeter of a part just by drawing it on graphing paper, then dropping in those XYZ locations right here in the middle of this program. Now this is not a how-to video, it's just showing you which codes you need to study first kind of video, but we'll give you a quick definition of each of these right now. This code is bookended by percent signs, both at the top and the bottom of the program. Our legacy controls require this, and the new ones can get away without it. but it's always a good idea just to throw them in. Now on our very first line, we have our O number. That is an O, not a 0, followed by a unique number that serves as our program identifier. The text behind, right after our O number, is in parentheses. Text in parentheses is typically ignored by the program. It's just a comment that we leave for the operator. Next line, we've got our M6T1. This is our command to put tool number 1 in the spindle. The next line is M3S7500. Now that line commands our spindle on and off in much the same way that we would command our cordless drill to work. An M3 is like pressing the forward button. It makes our spindle turn clockwise. If we press the reverse button, that's like commanding an M4 on our spindle. It makes the spindle turn counterclockwise or anti-clockwise. And the S7500 commands 7,500 revolutions per minute. That's just how fast the spindle will move. Now we're not going to go too far in depth on any of these codes. We're just giving an overview here. The real benefit of this whole video is just showing you which codes you gotta know. G54 is a particular work offset that this part uses. It references the G54 row on our work offset page. Now we've made whole videos on this, so be sure to check out the links. G0, G90, G17, these codes are part of what we call our safe startup line. The G0 commands a rapid move. It's used to go fast, not for cutting. G90 commands absolute mode, which just means that all of our X, Y, and Z moves are referenced off a single 0 point. The same way there was a 0 reference point at the center of our graphing paper. G17 is our plane selection, which lets the control know we are drawing machining in the XY plane. Here we have our XY starting position. Now it's where our tool will go first, like the first XY position of our first shape that we drew on graphing paper. G43, H1. Now these codes work together to let the machine know where our tool is in relationship to our machine and our part, in the Z axis, along the Z. Now we usually use H1 if we're using tool 1. Now they typically match. H1 references the row 1 on the tool offset page. We've also got a Z move on this line. This is the very first Z move of the program. You never, ever, ever, ever want to command a Z move unless you've commanded a G43 H something, H that matches your tool number, beforehand. Otherwise, the control is not going to where that tool is in space. Now we've made entire videos on this, so check them out. Check out the links in the description. M8 turns on our coolant, M9 would turn it off. And now we come to our first feed move, G1, Z minus. Now G1 just means that we want to machine in a line, just like our dot to dots. This G1 feed move always requires an F feed rate, which is in inches per minute or millimeters per minute by default on your machine. And we're back to dot to dot. Dot to dot is where we enter in all of our XY locations, the things that we want to draw, the shapes. But between each shape, we've got to have a Z move to get us back up and off of the part. So again, G1 is for machining, feeding from point to point. G0 is for rapiding from spot to spot, between shapes, between cuts. And when we're all done, we wrap it up, G0, off of our part in the Z, and then we end the program with an M30. If you are an operator and you want to machine, you want to program, start here. Learn these codes first. If you're a student and you want to get ahead in your G-code programming class, start here. Now, once you've created your code, you'll want to check it. We can run this in graphics on the machine. Press the graphics button, set your offsets, let it run. But I'm going to show you our desktop mill right now. Now this desktop mill typically runs a tiny end mill to machine out parts, but we have a pen attachment in it right now, which allows us to proof out our programs and to practice our code writing. It's just perfect for this type of testing. Well, that is it for this tip of the day, pretty much. Remember, start here. You got to learn all these codes. Well, before you go, be sure to hit the like button and be sure to download the bonus content that we link to in the description. Not only do we have all these mill codes, these basic mill codes, we also have those same basic 9 lines of code for your lathe. Don't want to miss that. Basic mill, basic lathe. Next, we've got all the advanced codes for you, things that you need to learn next. And if there was a next, it would be find yourself a modern cam system. So much easier. Learn the G code and then move on to a cam system. Well, truly, thank you for letting us be a part of your success and for watching this Haas Tip of the Day. Everything for me begins with my setup sheet. So check this out. I've got a block loaded up. Now, if you're tightening up those tools by hand,